So before I talk about case one, case two, stuff like that, we have solved some equations this year by graphing. Okay, here comes the question. Because we've been having some difficulties with these. How do I solve any equation by graphing? Any equation. But what if it's not an x squared? Any equation. Any equation. What happens if it's not one of those? What happens if it's a cubic equation or a radical equation? What's the general instructions? You guys should know this, and you're going to have to know this next year. What's that? Okay, that's part of it towards the end. What do you do with each side of the equation? What do you do with each side of the equation when you want to solve graphically? What would you do for each side of the equation? If you want to solve it graphically, graph each side of the equation. So you take each side, toss a y in front of it, and graph each of them. You guys have to know this. You guys did it with quadratic equations. You solve them by graphing. But this works with any equation. All right, let's graph this first, because we should know this. What's that?
Right.
It's a horizontal line through y equals 5. So find y equals 5 on your graph. There's a whole bunch of them where y equals 5, but we could just do right on the y-axis and draw a horizontal line. You guys usually have to graph y equals 0, and then in part of your solutions, many of you didn't graph it. How do I graph this? Well, we should know how to do this. We just learned it. What do I do first? You guys just told me how to graph an absolute value equation. So graph y equals x minus 3, which is y equals mx plus b. So what's my y-intercept? -3. And my slope? 1 over 1, which means I go up 1 to the right 1, and I keep doing that. You want to graph this accurately to get the right answer. Okay, so I graph y equals x minus 3. What's absolute value of x minus 3? What do I do? This is x minus 3. I want absolute value x minus 3. What's that? Everything that's below, flip it over the x-axis. So this is going to flip up here, and then you can just sort of follow that there. And so what I'm going to do is, you can also graph it like that if you want to. Remember I said you have to make it clear? You could do it like that. That makes it clear. Okay, so we've graphed y equals 5. We've graphed each side. Y equals 5. Y equals
Now what? I'm ready to find my solutions. How do I find them? I can't.
Where did they come together to make the word?
Just that. Yep. But I don't want the point. Remember, we're solving for x, right? So I only want the x values. Some little lightning bolt arrows. And what's x here? What's the x value of this point?
-2.
-2. What's the x value of this point? 7 or 8? I think it's 8.
That works with any equation. But obviously, it's not very efficient. We want to be able to use algebra.
So to solve it algebraically, so I'm going to add this here. Find x values of intersection points. That's how you graph all the time.
And it doesn't matter what's on each side. It doesn't matter whether it's a line. It doesn't matter whether it's absolute value. It doesn't matter whether it's square root, although you don't know how to graph that one. It doesn't matter whether it's a quadratic equation. You do know how to graph that one. You find the vertex first.
Okay? So algebraically, we can use a little logic. I'm just going to rewrite this. X minus what does this have to work out to? So that when I take the absolute value, I get this. What does this have to work out to? No. What does this whole thing have to work out to? 5, right? So if x minus 3 equals 5, and guess you solve, you get 8. Yeah, you guys were sort of getting ahead. What else could it be so that when I take the absolute value, I get 5? What else could this work out to? Hang on, you're actually too far ahead. What does this have? This has to work out to 5, so x is 8. This can also work out to -5, which means that x, when you add 3 to both sides, is -2.
So you actually get two answers. And notice the beauty of mathematics, it matches. Of course, it has to. See how it's all connected.
However,
Just like radical equations, I have to check my answers. Because sometimes when you work with absolute value and you solve, a solution you get won't actually work when you plug it back in. Bless you. Do you remember the name, what we call that? A what kind of root? Where we think it's an answer, but when we check it, it's not.
extraneous, thank you. So we have to check for extraneous roots. So is the absolute value of 8 minus 3 equal to 5? Yeah. 5 equals 5, we're there. How about the absolute value of -2 minus 3? Does that work out to 5? Yes. Because -2 minus 3 is -5, and its absolute value is +5. So these two are good. Can you see a bit of a shortcut?
Whenever I have an absolute value equation, I make two equations.
I take out the absolute value bars. And then I solve the equation that looks exactly like this, right? But then I take out the absolute value bars and I solve the negative of this. So that's what we can do when we solve, when I say case 1 and case 2. So remove absolute value bars make equation equal to positive of the right side. So when I took out the absolute value bars, I got x minus 3 equals positive 5. But then I can make a second equation by taking out the absolute value bars and saying that x minus 3 equals the negative of the other side, or negative 5. Follow me? So remove absolute value bars. Make equation equal to the negative of the right side. And then we have to check our solutions. So it's kind of like I said, it's kind of like when we solved radical equations. We got the radical by itself, then we squared both sides to solve, and then we had to check. With absolute value, you get the absolute value bar by itself, but then make two equations, solve, check your solutions. So let's look at a couple other examples. So let's solve this equation. So when we have an absolute value equation, we're going to make two equations and take out the absolute value bars. 2x minus 5 without the absolute value bars is equal to the positive of the right side, which is just the same thing, right? You got to be careful here. 2x minus 5 is then equal to the negative of this side. What's the negative of 5 minus 3x? Negative 5 plus 3x. Excellent. Because the negative has to apply to everything. And now it's just straight algebra from grade 9. Add 3x to both sides. Oops. 5x minus 5 equals 5. Add 5 to both sides. Let's see, 5x equals 10. Divide both sides. A potential answer is x equals 2. What's the other potential answer? Well, this time I'm going to subtract 3x from both sides. So I get negative x minus 5 equals negative 5. Now what? Add 5 to both sides. What's negative 5 plus 5? And how do I change from negative to positive? Just change it to positive, but then you got to change the sign of this side. Well, what's the negative of 0? Still 0. So those are my potential solutions that I have to check. And remember, you have to check it in the original, not in these ones. It has to work in the original. So does 2 times 2 minus 5, absolute value, equal 5 minus 3 times 2? have that right? 5 minus 3x? Yeah. What does this work out to? 1. What does this work out to? Oh, good, baby.
Oh, good.
Let's try 0. 2 times 0 minus 5, and take the absolute value. Does that equal 5 minus 3 times 0? Yeah, this works out to -5, and then the absolute value is +5, which does equal 5 minus 3 times 0.
So our only good solution
Is 0.
What do you think I have to do here first? What looks different in this one about the previous two? There's something with the absolute value, right?
Remember, we don't split it up into 2 equations until we have absolute value by itself. So I have to move the 12 over.
Wonder if somebody can tell me the solution of the solutions right now. Just out of curiosity. I mean, it's hard to see, obviously, but you have to understand what absolute value means, because I would look at this and I'd say there's no solution.
The question is why? Well, let's see. So we split. 3x minus 4 equals -3. The exact same thing without the absolute value bars. And 3x minus 4 equals the negative of this side, which is what? 3. So 3x is equal to 1. X is equal to 1/3. Three x is equal to 7. X is equal to 7/3.
So I got 2 answers, but remember, I have to check them. And remember what I said, I think there's no solution.
So if we check this, we get 3 times 1/3 minus 4, take the absolute value, add 12, and does that work out to 9? And then I got to check to see whether 3 times 7/3 minus 4, and then take the absolute value, plus 12 equals 9. Well, 3 times 1/3, 1 minus 4, absolute value, plus 12, 15 does not equal 9, no good. 3 times 7/3, 7/3, 7 minus 4, absolute value, plus 12. Does not equal 9.
No solution. I used to give this as a 1-mark question.
Because you actually don't have to do any work. Whatever this works out to, I have to take the, whatever this is, it's hoping to work out to a positive. No. Yeah, whatever x is, whatever I plug in here for x, calculate this, and then take the absolute value, it's going to work out to a positive, isn't it? Well, then it's impossible to equal -3.
So therefore, no solution.
Yeah.
See, like, this subject is just crazy. Like, how can you not see the beauty of it? All right. That's when you get a chance to work on your exercises. Talking away like crazy. And now I'm talking here, and nobody's saying a word. Oh, look at this one. What's first step? Get the absolute value bars out. Make it equal to the positive of the right side, which is the exact same thing. Take the absolute value bars out and make it equal to, sorry, negative. And now we got to solve each one. How do I solve these? What's that? Move the one over time. Right? Anybody got the factor form? See, looks like concern. Can you factor it? No. Which means how do you solve it? Quadratic formula we have to use. All right, here we go. Do we remember?
Negative b. Negative b plus square b plus b squared b plus b squared b minus b is minus
So what's b? So it becomes positive 2 when I put it here. Over 2 times 1, which is 2.
All good?
negative 2 would be in front.
Thank you. Should be in parentheses. Whenever it's negative, put it in parentheses. See, I know how all you guys operate.
So
4, 5 plus 4, 8. Again, how do you simplify? 8 is really 2.
oh wait, no, just like that, right? The answer's right in. Don't you dare do this! What have we talked about? You can't just get 2 out of the 3 and cancel. It's like doing this. No. How can anything plus 1, like 5 plus 1 divide 5 is 6 over 5, right? How is 5 plus 1, how is, if x is 5, how does it work out to 1? That means anything plus 1 divide the original number is always 1. And that's just crazy. Anyway.
2 1 minus 2 square root.
Thank you. Well, 2 plus or minus. This simplifies to 2 root 2. Now, hey. Now I can divide all of them.
Yeah, it's 2 root 2. What's wrong with you? So what's the final answer?
Oh, what?
What? What? What? Plus minus root 2? You are killing me, like slowly. What's this? Divide 2. Thank you. This is 1, this is 1.
Yeah.
So it's 1 plus or minus root 2. Yes, it is awkward. Hello. Oh. They got excited for a second. It's like, who is it? Oh. This one's much easier. Because this one you can actually find. Negative 1, negative 1. I know, it's fun. Stuff that we're doing today. So what are my solutions here? 1. Because it's 1 for both factors. Okay, this one we're not going to check. Because this is pretty ugly to check. 1 plus or minus root 2. When you plug it back in, because it gets very complicated. So sometimes read the instructions carefully, especially if I give you a quadratic absolute value. I may say you don't have to check your solutions. Okay? Because that's a lot of work. So we'll leave it at that. We'll assume that both of these are that, sorry, how many solutions are there? How many answers did I get? 3. We'll assume that all 3 are, what if we check them, they're